We can also use confidence intervals for hypothesis testing. Consider the case where we have a null hypothesis saying that a particular population average is equal to a number, x, and the alternative hypothesis that says that the population average is not x. In order to determine which of these two hypotheses the evidence favors, we need to first set a cutoff value for the decision, and we'll call that level p. P might be 1%, P might be 5%. Really depends on your application. The method for implementing a hypothesis test using a confidence interval is that you first construct a 100 minus p% confidence interval for the population average in this case. And if x is not in the interval, then you reject the null. And if x is in the interval, then you fail to reject the null. Let's first load the table of births into memory using the baby.csv file. This is the table of data from all the mothers, and we include their maternal age. We're interested in determining whether the mean maternal age in the entire population is 27 years old. I claim that the true population parameter of mean maternal age is 27 years. Let's test this by resampling with a 95% confidence interval. We're testing whether the mean maternal age is 27, that's our null hypothesis, versus our alternative hypothesis that the mean maternal age is not 27. We've already got a sample of mothers in our births table, and we can resample to create a 95% confidence interval. Here's a histogram of the maternal ages. It looks kind of vaguely plausible that the mean age might be 27. And if we compute the statistic for this particular sample, the mean age is 27.2, again, seeming kind of consistent with our null hypothesis claim. Let's run the bootstrap. We'll do 1,000 different replications. For each of them, we'll resample from the births data, and we'll calculate the mean of the maternal age column in the resample. And then we'll add that in to an array means that we've made to contain all the 1,000 means. At the end, we'll make an array that contains the left endpoint and the right endpoint of a 95% confidence interval. Let's put this data into a table and plot it. Here's the histogram of our resamples. There's 1,000 resamples here, and it looks roughly bell-shaped as expected. Here's the true or at least the claimed mean age, and note, and we've also got the yellow confidence interval here. And because 27 lies inside the confidence interval, we should fail to reject the null hypothesis. It seems that 27 is kind of a reasonable claim for the mean age.